Afternoon, guys. It's Mr. Kilburn, and by now you have finished quiz 2. You've gone over it. Hopefully you didn't change any answers unless you were 100% sure that it was wrong, and hopefully you did really well. First quiz went just phenomenal. Proud of you guys. So keep it up. Doing great. It's already a new month. One of the long months are down, and we're well on our way to Christmas and winter, and just another school year going to fly by. So this next topic that we're going to talk about, students tend to like a little more because it's more visual. There's shapes involved and just things that they can visualize better than, 2.1 times 10 to the negative 18, right? I get it. It's a huge number. Like, what does that even mean? So this is a little more visual with respect to geometry. So the topic we're going to talk about is something called congruence. And congruence has to do with proving that shapes are the exact same size, exact same shape. And there's 3 ways we can do that. 3 rigid motions, as it were. So the first rigid motion I'm going to briefly talk about here is something called a translation. And a translation, and I'm going to use this Desmos widget to help us talk about it. So basically what will happen is I can take a shape and translate it along this line. Okay? And basically I'm just sliding it. Okay? The shape is rigid. It's not flexible. It's not turning into a triangle. It's not turning into a diamond or whatever. Okay, it is what it is. It's just sliding along this line. Okay, so a slide, a translation, is definitely a rigid motion. Okay, and I can prove these 2 shapes are congruent, so I'll just slide it back, and they match up perfectly. Okay, so those 2 shapes are congruent, and I can prove it by a translation. The next one is a rotation. Okay, so a rotation, it's what it sounds like. It's a shape that's being rotated around a center. All right, and you may say angle. How's that angle work? Well, suppose I said I have a rotation of 90 degrees. Let's see if I can get it right on 90. Oop. Right there. Okay, so the reason this is called a 90-degree rotation, because if I take this point, draw a line to the center of rotation, and over to where I ended up, it makes a right angle. Right there. Okay? Or if I drew from, let me erase that here. Yep. Suppose I wanted to draw, say, from this point down here, that also would make a right angle. All right? So it's not, when we rotate, we're not just making up numbers or saying, oh yeah, for the heck of it, we're going to say it's a 90-degree rotation. No, not at all. It's a 90-degree rotation because from what's called the pre-image point, where you start, to the line of rotation, from the angle of rotation. So from where I start, here, the center, down here, okay, this, the beginning point, it's called a pre-image, right here. And here's where I end up, it's called the image. All right, it actually makes a 90-degree angle. But again, it doesn't have to be 90 degrees, it could be just about anything. Okay, I could do, oh shoot, go away. It could be a half turn, so 180, right about there, or all the way around be a 360. But either way, this is rigid motion because I keep going back and I can get it to match up with the original shape. And it matches up, and it matches up. Okay, so that's a rigid motion. This, arrow-looking shape, and wherever I put that center of rotation, it's kind of cool. Okay, wherever I put that center of rotation, the shape's just going to rotate around it, always maintaining the exact same side length, same measure, same angle measures. Everything about it's going to be the same except where it's located. And again, I can work backwards by a rotation and get those 2 shapes to match up. So they're what's called congruent. Same size, same shape. Okay, last one we're going to work with is a reflection. So this shape was reflected, okay, over this line of reflection. And what's kind of cool here is the pre-image point where you start right there. Whoop. Hang on. Sorry, guys. Technical glitch here. Why aren't you? I don't know what's going on here. Anyway, this point here and this point here are equally distant from the line of reflection. If I was to draw a line, there we go. If I was to draw a line from here to here, this distance from the original shape here to the image over here, this distance is the same as this distance. And it's true for every point. Okay, each point from its pre-image point where it starts to where it ends up is equally distant from the line of reflection. Something called orientation. So let's suppose this shape has a counterclockwise orientation. This one's going to have a clockwise orientation. But either way, if I reflect this back over the line of reflection, let me erase this here. If I reflect this shape back over the line of reflection, it'll end up on top of that one. Okay, so sometimes it's called a mirror image or a flip. All right, but it's another rigid motion. This shape is not going to turn into a rectangle or square, rhombus or whatever. Okay. Lastly, just a little note here. So the word rigid means unable to change its shape. So if it starts out as a triangle and you reflect it or translate it or rotate it, it's going to end up as a triangle. Or if it starts out as a square, it's going to end up a square, whatever. So you can use fixed, rigid motions to prove shapes are congruent. Again, congruent means same size, same shape. And there's lots of different cool exercises we'll talk about as a fun activity we're going to use with cameras and symmetry. We'll have a good laugh when we get to that. Okay, so there's your brief intro to congruence, same size, same shape. Hope you enjoyed it, and we'll talk to you soon. Later, guys. Bye-bye.